So this is the third solution video for the 2019 physics exam from June, and this would be part C. And so we're starting with oppositely charged parallel plates and an oil drop. So it says we have questions 66 through 70 using the info and diagram below and your knowledge of physics. So a diagram shows negatively charged oil drop, so that oil drop is negative drop. Suspended motionless between two oppositely charged parallel horizontal metal plates. Electric field strength is 4 times 10 to the 4 newtons per coulomb, so we know what E is. 4 times 10 to the 4 newtons per coulomb. And then the mass of the oil drop is given 1.96 times 10 to the negative 15 kilograms. And acted on by a gravitational force and an electrostatic force. So 66, 67, calculate the gravitational force acting on the oil drop. We can do that by doing the weight equation because we know the mass. You can do weight equals mg. I'm going to use the version as written on the ref tab. G is weight over mass, and so we know the mass is 1.96 times 10 to the negative 15 kilograms, and we're solving for force due to gravity, aka weight. We wind up with a weight of 1.92 times 10 to the negative 14 newtons. All right, then for number 68, it wants to know what is the upward electric force acting on the oil drop that is suspended motionless between the charged metal plates. And so since it's at rest, the net force is 0. That must mean the upward electrostatic force balances out the downward weight, giving no net force. And so that upward electrostatic force must equal the weight, 1.92 times 10 to the negative 14 newtons. Of course, if you got 66, 67 wrong and carried that forward into 68, you would not get 68 wrong. It'd be error carried forward. And then 69, 70, they want to know the charge on the drop. So we use E equals F over Q. And then we put in the electrostatic force that was given in the problem. We put in the electric field strength that was given in the problem. We put in the electrostatic force that we just solved for, and then we cross multiply. Q is 4.8 times 10 to the negative 19 coulombs, which makes sense because that is divisible by 1.6 times 10 to the negative 19 coulombs. That would be 3 electrons. That's a pretty small drop, but it does make sense. Okay, so there's that set. Now we're on 71 through 75. Okay, we have a 100 ohm resistor and a 200 ohm resistor connected in parallel to a 10 volt battery. 71, 72, find the equivalent resistance of the circuit. That would be Req, and we're dealing with a parallel circuit, so we have to use that old fraction equation. Okay, so the resistors are 100 and 200 ohms. The total resistance is not 300 ohms. We do not simply add the resistances in parallel. And be careful, this does not equal 1 over 300, right? Don't add your denominators. You don't even need to mess around with least common denominator. Just add the fractions. 1 over 100 plus 1 over 200. You get 0.015. 0.015 is not Req. 1 over 0.015 is. So we go for the R equivalent, 1 over 0.015, and we get 66.7 ohms, which is fitting because in a parallel circuit, the equivalent resistance will be less than the individual resistors. Then it wants the current in the 200 ohm resistor. We're looking for current, R equals V over I, so I equals V over R. And then we know the resistance of the 200 ohm resistor, and we know the voltage across the 200 ohm resistor. So we get 10 volts over 200 ohms. And we get 0.05 amps. Now, why is the voltage 10 volts? All of the voltages are the same in parallel, and so if I know that the total voltage, the 10 volt battery, if I know the total voltage is 10 volts, then that is also equal to the voltage across the 200 ohm resistor. So yeah, 0.05 amps for the 200 ohm resistor. And then it wants to know what is the power dissipated by the 100 ohm resistor. Well, one of the power equations is V squared over R. And for the same reason that there are 10 volts across the 200 ohm resistor, there are 10 volts across the 100 ohm resistor. So we do 10 squared over 100 ohms, and we get for power 1 watt, 1 single watt. So those are our answers for those three problems. All right, that's the circuit problem. Let's move on. 76 through 80, it says we have a wave traveling through a medium and its amplitude is 0.2 meters. Its wavelength, so we have A, even though we don't have any formulas that feature amplitude, but I'm going to write it anyway. Amplitude, 0.2 meters. Wavelength is 0.4 meters. And the frequency is 10 hertz. I bet they're going to want the speed now that they gave us the wavelength and the frequency. On your grid in your answer booklet, draw one complete cycle of the wave. I don't have the answer booklet right here, but I can imagine what it looks like. Grid's going to look something like that. And you want to draw one cycle. So the wavelength is 0.4 meters, and so I have 0.4 meters drawn out here. So, and the amplitude is 0.2. So I want it to go half of it will go to there, and then the other half will go down to 0.2, and then complete in 0.4. So the full cycle is 0.4 meters long, and then the amplitude goes up to 0.2. Keep in mind that amplitude is the height of the crest or the depth of the trough. It is not from crest to trough. Also, make sure that your cycle, halfway through the cycle, hits halfway through. So half a wave should hit 0.2. Calculate the speed of the wave. Call it V equals F lambda. So that's going to be 10 hertz times 0.4 meters. And that is 4 meters per second. Pretty basic. And then determine the period of the wave. Period we know is 1 over the frequency. We have the frequency is 10 hertz. And 1 over 10 is 0.10 seconds. Not too shabby. All right, and then the last question set deals with a graph. And, oh man, they want me to make it a graph. I don't have the answer book. I'm going to have to draw a graph. Okay, so we have to make a graph. We have voltage versus current. And so plot the points, draw the line or curve of best fit, calculate the resistance of the resistor. It's pretty basic. Let's take care of that. So here's the graph that they gave in the data booklet. They actually put voltage on the y-axis, which is a little weird because usually the first column is x and the second column is y, but whatever, they put voltage on the y-axis. And they said scale the current axis. So our current goes up to 0.0244. And I have 5 marks on the x-axis, and so probably what I could do is go up to, and so they have 0.0244, the top number could be 0.025, and we can go by 0.005s. So there's the scale, going by 0.005s up to 0.025. I should probably grid out my drawing. So here's our scale, and it says plot the data points for current versus potential difference, and the potential difference goes up by 3s. And so let's do that. Actually, starts at 1.5 and then goes up by 3s. And so my drawing is kind of sketchy, but the plot should come out rather linear. And so then they want the line of best fit, so we draw a straight line through the midst of the points. That should do pretty well. So then there's a line or curve for best fit, and it says using your graph, calculate the resistance of the resistor, and the resistance we know is the slope. So I picked 2 points on the graph. First point is 0.021 amps roughly and 10 volts, and then the earlier point 0.005 amps and 2.5 volts. Be careful with those zeros, that you're reading that carefully. And so what we wind up with is, and so based on my sketchy drawing, I get 470 ohms for resistance. The actual answer key says 500 or consistent with graph. So, and 470 ohms would be consistent with my graph, so it would get the points. But I'm sure that if I actually made my graph on an actual legit plot, I would get a better result. larger graphs lead to more accurate answers. But that is the end of Part C, and that's the end of the 2019 Regents. So, thank you.